Hey, Shashank. Hello, everybody, and welcome back to the number one generative AI meetup podcast in the world.
That's right.
Yeah, we've been experimenting with the intros. Sometimes we were trying to just get into it. But today, I want to just introduce ourselves. I saw that in the analytics, our total number of listeners has been increasing. So if you're listening, thank you.
Yeah, wherever you are, in whatever part of the world, thanks for paying attention. We try our best to think about interesting, relevant things to talk about. And this week, it's, I wouldn't say it's been a slow week, because, in the fast pace of AI, we have ridiculous announcements every week. We have some impressive news, but not radically different. So the one that's been on every news outlet is the fact that Claude's biggest and best model has overtaken GPT-4 on these leaderboards where people get to vote on which model is better by looking at the output of some of these models.
In other words, there is a new king in town. Where it used to be, GPT-4 was just dunking on everybody else. Now,
For close to 2 years, or a year and a half.
a year, yeah, crazy. And GPT-4 has finally been overtaken. OpenAI is no longer the king. Now, the new crown has been handed to Anthropic's Claude Opus model, and OpenAI is sulking away in second place. So we'll have to wait to see what happens with GPT-5. But for now, OpenAI is fighting again from second place.
I'm not too worried. Like we mentioned, so just to clarify, GPT-4 was released just about a year ago, almost exactly a year ago. I see an article from like March 14th. But this kind of feels similar to the NVIDIA-AMD rivalry where, AMD released like new GPU chips which beat the H100s. And fast forward a couple months, now we have the B or GB200, whatever, that blows it out of the water again. So I think it's just a matter of time.
Yeah, I think you're right. I think that I'm happy that there's so much competition in the space. So you may be wondering, like, how did somebody even determine what is the number one model? So basically, there's a website, and it's like, I think it's called like AI Leaderboard, but it shows two different text prompts where the name of the model is hidden. So if you've ever, asked ChatGPT or any of these models a question, basically there's like a text input where you type in the question that you have, and then there will be two answers from two random models. And then you'll just go and pick like, oh, I like model 1 better, or I like model 2 better. Or maybe it's a tie, or maybe they're both bad. And then they have just thousands or millions of people going and asking questions to these models, and they're just constantly rating them. So it took a while, a couple weeks from when the new Claude model was launched before it overtook OpenAI, but it's there now, and GPT-4 is now in second place. So it's exciting that these blind, I was going to say blind taste test, but I guess in a certain sense, it's like blind model judging. People like to choose the Claude models. It's also, I would say, in a certain sense, somewhat subjective, because I think a lot of the models have like their own kind of style in a certain sense, where the Claude model tends to write in a certain way. And I feel like at this point, I've kind of gotten where GPT-4, I'm not going to say like I can tell that it was written by GPT-4, but I feel like oftentimes like things that were written by GPT-4 have like their own sort of style where you can tell. I was actually listening to like a podcast the other day where they were interviewing admissions counselors in school, and they said that they found that there were certain phrases that if they saw this phrase was used, they just assumed that it was used by, or like generated by AI. So I feel somewhat sorry for the students who like actually just use that normally, and their application was rejected because the admissions counselor just assumed that it was written by AI. But yeah, maybe they should use Claude.
That's funny. It's nice that we have an open source subjective leaderboard like this. So this is something you can find on Hugging Face or the actual website that does this, called lmsys.org, lmsys.org. And it's actually a fun way to use a bunch of these models for free. You don't really know what you're getting in advance, but at the very least you'll get two outputs, and you can compare the two and pick whichever one you like.
Yeah, so for those that don't know, Hugging Face is just a website where you can download a bunch of these open source models. So they have like, I don't know, thousands, hundreds of thousands of like AI projects that are all open source. And not just AI models, but they have like AI data sets. They have a bunch of stuff that you can go and download and use for free. So it's almost just like a shared file storage and sharing platform for all these things. So anyways, sorry.
Yeah, no, that's a good point. It's become one of the most popular places for people working on these tools to go to. I think they're funded by Sequoia and a bunch of different high-profile VCs. And it's so silly. Their logo and their name is just like the smiley emoji with the two hands that's meant to be like a hug. So that's what it is. It's like the hugging face emoji. And that's the company. Welcome to 2024. But yeah, so what I was trying to say is we knew that Claude's new Opus model was better than GPT-4 from standardized tests, which were used in the benchmarks from their paper. But this is like a good sanity test to verify that those benchmarks actually have real world noticeable difference for end users, which is really nice.
Yeah, that's true. So Shashank, you're also mentioning, so yeah, you know, we're talking about Claude Opus, but there's a new model which
oh my god, yeah,
it isn't as good as the Opus one, but is interesting in its own way because it's open source. Shashank, this new Databricks model, you want to talk a little bit about this?
Yeah, that's right. So we have these two polarities. We have these closed source models, ChatGPT being the biggest. But to be honest, just before we get into the open source world, closed sourced ones, Claude's Opus is better than GPT-4, but I don't remember if we saw comparisons to Gemini Ultra. That's another one that's missing in this leaderboard, maybe because they don't have access to the API, but for whatever reason, this LMSys leaderboard that's also available on Hugging Face, which is the crowdsourced one, it doesn't have Google's biggest and best model, which is, take from that what you will. But in the leaderboard, we have Google's second biggest model that's right below Claude and GPT-4. So I feel like if we add that in, we'll have another new king of the hill in closed sourced.
I don't know. I don't think that you would see the Gemini one beat Claude Opus.
You don't think so?
No, I don't think so. I've used them both, and I keep honestly, to me, I keep going back to GPT-4.
Oh, even over Claude.
Yeah, and it might just be because like I have subscription fatigue,
maybe,
and I don't want to just continue like paying for the subscription. And I like using some of the things from ChatGPT, or I should say from OpenAI, that Claude doesn't have. So ChatGPT has the entire like agent store, I think it's called.
Yeah,
and you're able to use that. So the agent store is basically a bunch of programs that were built on top of ChatGPT to do certain tasks. So, for example, one is from Figma, where I'm not Figma, but Canva. And Canva, you can put in a prompt, say like, I want like a PowerPoint presentation for our meetup group. And it could go and create like a beautiful PowerPoint presentation. Or it's not
with
like,
animations too.
Yeah, with animations. Or I shouldn't say PowerPoint. It's like, because it's not like the Microsoft one. It's
a slideshow.
Yeah, slideshow, Canva specific. But still, I think you probably save it to PowerPoint, and it's really good. There's another one where I think the number one agent is by consensus. So consensus allows you to search a bunch of different research papers. So these things and integrations with all of these extra tools is something that Opus doesn't have. So I think that like in a sandbox, answering questions, I think Opus is better. But as an entire platform, I think I still prefer ChatGPT.
Yeah, agreed. So just the LLM's chat interface is one thing. And then on top of that, you add, uploading documents, images, maybe add like a voice chat interface. And then on top of that, you add an agent store, which allows other people to build custom versions of ChatGPT with their own like system prompt, which just kind of goes before your prompt as a user to give their version of ChatGPT additional context, maybe give it additional actions. And then boom, you have a really solid differentiator against all these other companies. But none of these seem that cutting edge. I feel like the hard technical challenge is building these models, training them, finding good data, and tweaking the architecture or doing some reinforcement learning, RLHF, to make these models better from the research perspective. But all the other stuff, maybe I'm just talking as a software engineer, but all the other stuff seems pretty easy to build on top of it.
I agree that the hard technical problem is building these large language models. And I think that that is like a super amazing technical challenge that, the team at Anthropic did. So I think hats off to them. But I think that, we can't discount the network effect that those agents have and the ease of use. So like, it's true that like technically, the agents aren't necessarily that hard to necessarily build, but realistically, I don't think Anthropic could build out the agent store by themselves without like open sourcing or like leveraging to the community. So like right now, the agents are built by tons of different companies and people. And that's like a lot of mind share, just like actively, building things. Right. And I don't, unless like Claude or Anthropic, unless they like opened out their own store for people to start like profiting their own agents, I just don't see them competing yet.
I can see them doing that pretty soon because it seems like everyone is following in the footsteps of ChatGPT or OpenAI rather. Whatever they do, everyone else follows. Since they have built a GPT store, and you mentioned a really good point, subscription fatigue. So if you're already subscribed to OpenAI's ChatGPT, then you're most likely going to stick to it for a while. And then you get a bunch of add-ons like custom GPTs from other people for free. I feel like that's a great value add.
Yeah, I think so. And also, like, I think that the switching cost is somewhat high because, like, if you already have, like, your workflow built out with GPT-4, even if, like, Claude is marginally better, which I think
not worth it.
It's like you may just not want to change up like your entire workflow to a different company. So I think that like in order to win, they need to be not just like, moderately better, which I think they are, maybe let's say 5-10% better, right? They need to be like, they need to be like 100 times better, or not 100 times better, or at least twice as good, right?
Significantly, yeah.
Yeah, it needs to be significant. Like in a certain sense, it kind of reminds me of like Windows Phone a little bit. So, like you had like
I had a Windows Phone, yeah.
Yeah, it's like, a lot of people would say like the Windows Phone was like technically better. So maybe, right? So it's like,
It's just a different flavor, just like all these other elements.
right. There's like iOS where you have the whole app store, Android where you have its own app store, and then like Windows Phone was just like had like just a couple percent like market share.
Oh, nothing. They had nothing on their app store. I remember that.
Right. And I think that like, like these things in a vacuum, you might say like, well, Windows Phone, I like it. It's maybe better for whatever reason. Maybe you like the camera,
Square tiles.
Yeah, the square tiles, the color scheme, whatever. Like maybe it has better battery life. But like at the end of the day, it's like you want the app store because that's the most important thing.
Yeah.
Right. Like you want your banking app to be there. And if it's only on the iPhone or only on Android, like you're not going to switch to something else. And I think that the GPT store from OpenAI isn't quite as sticky as those apps from like iPhone or Android.
Yeah.
But I do think that like it does add some stickiness to make it harder to move away.
Yeah. So speaking of agents and building like apps on top of GPT, I think we've seen a rise in agents, which is basically running these LLMs in a loop with some kind of heuristic that mimics human thought to have them keep prompting themselves over and over again and achieve like a higher goal. So one of those high-profile agents was Devin, which is like the first software engineer. And now we see an open source version, Devika AI, which is supposed to replace or duplicate all the features that Devin had. And I think we're seeing a big rise in open source agents. Ever since ChatGPT 3.5, we had like Baby AGI, AutoGPT. Then, of course, LangChain, which allows you to build agents from scratch. It takes a little bit more effort, but you have more control over how you build these agents. And now you have tons of frameworks. You have Microsoft's AutoGen. You have Crew AI, which is another open source third-party solution to build agents. So I'm really excited by this open source world because these models are getting smaller, more efficient. We're seeing not just single large models, but these mixture of expert models. Because I think it was leaked or people guessed that GPT-4 is in fact a mixture of models, a mixture of expert model.
All right, so I think you lose a lot of I think we lost half the audience. It's okay. Can you explain what a mixture of experts model is?
Yeah. So I think with GPT 3.5, they took one large neural network, trained it on a bunch of different kinds of data, and then asked it to generate some output. But I don't understand the research intuition behind this, but it seems like if you train a bunch of maybe smaller or ideally bigger, but bunch of different models on specific use cases, you can get away with using smaller models to achieve the same level or higher performance on individual tasks. For example, say science or mathematics or biology or human social interaction, showing empathy and things like that. So if you have different models trained to excel at specific tasks, that performs much better than a single general model.
Okay, so what you're saying is...
And it's also cheaper to train.
So if I understand correctly, you'd say like, okay, I'm going to make a model where I just train it on, let's say, doing math. Mm-hmm. And it's like, okay, this is going to be super good at math, but if I ask it a question about history, it'll be like, I got no idea. If I ask it a question about cooking, it'll have no idea. And then I might have another model where I'm just training on like only like world history, everything history. Math, it has no idea. Maybe another one for maybe, let's say, economics, I don't know, or biology. Mm-hmm. And then I maybe have like, let's say, 100 of these different models all trained on a specific use case. And then I maybe have just one model to maybe take in the question and then route it appropriately to the model, and then have maybe the two experts sort of talk to each other. Would that be a appropriate way to kind of think about this?
Yeah, I think on a high level that sounds right. Although I'm not a researcher, so the fine grained details might be a little different. But the first team to at least first high profile team that did this was Mistral with their mixture of experts 8x7b, and those funky numbers show how many different models they used and combined them into one single model. So they used like 8 separate individual models. Each was about 7 billion parameters. And then they combined that to form like, a larger model that performs as good as some of these 70 billion parameter models, but as fast as a 7 billion.
So I guess the difference here is like the 70 billion parameter model or whatever, like these really big models is just like you train it on everything, like everything under the sun that you can think of, like economics, math, philosophy, cooking. You're going to just make it like one super genius. So like this is almost like Isaac Newton, just like it knows everything. And then the mixture of experts is kind of like you have a bunch of specialized people and then or models that are just like, all kind of working together. In a certain sense, I almost think my mental model is sort of like a company versus like a lone wolf, like super genius. Where like a company can oftentimes beat the lone wolf super genius because they're able to specialize collectively and then work together. Whereas a super genius might be like better than any individual person, but they're not working together. So it's almost like the mixture of experts is like a company, and then like the big model is like super genius who's good at everything. And I don't know, they both have the pros and cons, but I guess that's one way to sort of think about this.
Yeah, kind of. The way I think about it is this entire year has been, except for a few groundbreaking announcements like Sora, which is a massive improvement over the state-of-the-art video generation. Apart from a few things like that, this past year or two has been about eking out as much performance gains as we can out of the current approaches that we have. So mixture of experts, I kind of see that as being better in performance, both during training, because it's cheaper, it's faster, and during generation or inference, where you get the response much faster because you were using a smaller model. It's cheaper too compared to like a bigger model the same combined size. We have all kinds of like tiny little tweaks and optimizations. We have different chips that run these things faster, different architectures of these models, not just like the chips that run these transformer LLMs, but we have completely new alternatives to the transformer architecture. We have this Mamba architecture too, and companies coming out with different LLMs powered by Mamba, which apparently are pretty good at visual understanding. And along the transformer lines, we have Databricks, which released another state-of-the-art mixture of experts open source model called DBRX. And again, it's not like groundbreaking in terms of like a significant jump over the current incumbents.
DBRX, how do you pronounce that? Is that Databricks?
But in terms of performance, it's a few percentage points better than Mixtral, which I think is the state-of-the-art model right now. It's also better than Twitter's Grok model with a K. And that thing is like 300-something billion parameters, as opposed to this one, which is what, 7? Or a mixture of 7 billion parameter models.
Is Grok a mixture of experts model?
I believe so, yeah.
Interesting. Okay. So have you been able to play around, or what do you know about this new mixture of experts model?
Not a whole lot. I'm just looking at their announcement.
Okay.
They have a couple different evaluations. They have general language understanding with the MMLU benchmark, which is like multimodal language understanding something benchmark. they have math, they have programming, and it seems to be doing pretty good at all of these compared to the open source models.
Okay. Okay, so we're just comparing this to the other open source models.
Yeah.
I mean, that's fair.
I think that's fantastic because I see both of these benchmarks, like the closed source world and the open source world, both necessary in and working in two separate ecosystems because a ton of people want to run these models for free. It's cheap to run on your laptop, and the smaller they get, the faster they run, the more you can generate. And at some point, I can envision us running agents all day long, all night long, maybe. Like have an agent like do some higher level thinking analysis on some problem that you're trying to solve, keep it running overnight, and then you wake up in the morning and voila, it has a solution. Something that maybe took on the order of tens of hours to compute over several iterations, that maybe GPT-4 in a single prompt would not have been able to achieve.
So you're saying that like maybe you could take one of these open source models, maybe the new Databricks model, the DBRX one, or Mistral or something, whatever, one of these open source models, and then you just send it after some sort of task.
Yeah.
You're like, all right, hey, just think really, really hard about how I can make money. And then at the end of it, it's like, all right, it churns, thinks about it. It gives you a single word response.
Ideally, it would have like all the context of your entire life too.
Yeah.
That'd be nice.
And then it's just like, all right, put it all in Bitcoin.
You know? I think a lot of people would like that kind of advice, but you know, that's a personal preference again.
That's true.
It's all about the flavor of LLM that you want to ingest.
Yeah. So Shashank, what do you think are some like actual like realistic use cases for these types of agents?
Realistic use cases. Well, I was listening to a podcast by a bunch of VCs, Sarah Guo, Elad Gil, they're investors and who live in San Francisco, and they were talking about the prospect of one of these agents replacing their work, doing business analysis, competitive analysis, understanding, what this company's place is in the market, and they mentioned that it might be able to do a lot of work, but some of the subtleties of understanding, okay, is this founder like a 10x kind of person? Do they have the grit and what it takes to survive as like a startup founder? And a lot of those subjective evaluations might be challenging for these LLMs.
I don't think humans are very good at that either.
Yeah, that's true. At least not consistently. So it would probably be some kind of grindy work, something that's tedious, repetitive, simple enough at each step of the task.
I wonder if you could do some sort of like fundamental science research, like maybe something with like,
if it's tedious enough,
I don't know, maybe not even like tedious, but I could imagine maybe like running some sort of like experiments or something, where maybe if you had some sort of simulation of like a molecule or something like that, and you're just trying lots of different like combinations of things, and then like seeing how that interacts with the world, and then maybe doing that not like in a brute force way, but trying to like be more elegant about how you're like solving these like medical problems. I don't know, because I think like sometimes like in science, and I don't just not really exactly sure, but a lot of things like we just don't know. So like, for example, I was having a conversation the other day about statin use. So statins, most of the research that has been done has been on people that are older, and they'll say like, oh well, we don't have any data to show that like statins is useful for people that are younger, and like that doesn't mean it's not good for people who are younger. It just means that there wasn't any studies done. So like it could be, but it might not be. So like what I wonder is like maybe there's some sort of like simulation that you could do on like a simulated body where they could run like in computers determine like if statins are useful. I don't know if that could be done like just as like a simulation, but it's something that like I wonder if like some scientists could do.
That sounds really hard in my head. To try to simulate the biology of your whatever specific system that you're trying to target, maybe like the cardiovascular system, and at a specific age, level of health. I was thinking just like mind-numbing, tedious tasks that can be automated. So in terms of like pharmacology and biotech, I did hear about a company that was trying to automate the experiment process where they test a bunch of drugs on a bunch of different strains of diseases. So they were able to create some kind of robot that just tediously takes samples of this drug, makes small modifications, and then drops it into this petri dish with this strain of bacteria or something, and does that over and over again, like hundreds of thousands of times, labels it, records the output. Those are the kind of things that I think we can automate significantly.
So what if you did that with like young cells and then old cells and just like plop some statins in there and then just saw what happened?
You could, yeah, I can see that.
Right? So then like you could use that to...
Well, but I think the challenge with a lot of these drugs is you can't just test them in a petri dish. You need to test them in a human being's entire system.
Yeah, which might mean that we need to actually give like real live humans the drugs until we can
like
completely simulate a human. Maybe like AI could help us build a simulated human. I feel like that'd be pretty useful.
I feel like we might need a lot more GPUs than what NVIDIA has.
Maybe just a little bit more.
Just a little bit more.
Yeah, I think because we were talking last time.
1 doubling, 2 doublings, maybe.
I mean, I think we might have enough right now to be close to simulating a human, like with current day technology. Just if you string a bunch of GPUs together.
What would you need to simulate a human?
Man, I think you need a lot.
A lot of physics?
I mean, I would think that like what you'd want to do is if the body is made up of cells of different types, I would assume that like you would have to start with simulating an individual cell. I don't know like exactly what that would take, but
okay, so maybe physics and even chemistry is too low level. Focus on the biology of more complex cells and microorganisms that live in this.
I think so.
Ecosystem.
Maybe I don't know if that would be sufficient, but I think that in my mind would be maybe how I would approach it. I would look at the individual cell, try to simulate that, and then however many cells are in the body, I would just simulate all of them and how they interact with each other.
Yeah, I haven't heard too many biological simulations of this sort. Most of the research from medicine that I've seen focus on very specific niche use cases like protein folding. Well, maybe it's not that niche. It's a very common problem in a lot of biological use cases in medicine. But yeah, protein folding, that's been like the hot area of research for the last maybe 10 years or something.
So aren't the proteins in cells?
Yeah.
So then like, I guess like if you're simulating the cell, you'd have to simulate maybe some protein folding as well.
Right. So we're focusing on proteins that make up like and tons of different proteins might make up an individual cell. So I think we're just at that level where we can predict not even what these proteins do, but how they will look depending on what kinds of structure they have.
So that makes me sound like if we're just figuring out like protein folding, then
it might be a little farther out.
We might not even be like
simulating the entire human body,
or even just like a single cell. We might not be there yet, because if we can't simulate like an entire protein, then you can't simulate a cell, and until we simulate a cell, then we can't simulate the entire body.
Well, it depends on how you want the simulation to play out. Do you want to focus on like the physics and have atoms bounce around in the simulation and respond on the scale of like human motion.
I think ideally,
or you want to abstract all those things out and simulate a cell which has some characteristics and then does certain movements, and then that results in some motion inside your body.
Well, I think that like in order to like appropriately simulate like how a drug would interact with things, I think that you need to have like the atoms bouncing around and then just like measure that. I don't really know how many doublings we are away from that, but that sounds really hard. We could probably do some mental math to figure out how many atoms are in the body, but I think it's a lot.
Yeah, that might be a lot.
Yeah. Anyways,
I think just pulling out some rough numbers from anecdotal videos I've seen, take like a tablespoon of water, and I think there's more hydrogen atoms in that tablespoon of water than there are tablespoons of water in this entire planet.
Wow.
So it's like a lot.
This is a big number.
This is a big number.
Yeah. So I don't really know like exactly how you'd approach that problem, but maybe AI could tell us how to handle that.
Just throw a bunch of data at it, ask it to figure it out.
Yeah, it's like, hey, this is a human body. Like, can you go and simulate this for me, please?
If that doesn't work, just give it more data, more compute. Come back like 2 years later, faster, smaller GPUs.
Honestly, I feel like that might be like how we solve a lot of these diseases, is just like, get more and more better simulations of the body, so we could just like try more like permutations and combinations of like atoms and drugs and stuff, and just like kind of see what happens.
Mm-hmm.
And then maybe AI could just like figure out like what the patterns are and like what works, what doesn't.
Yeah, I'm sure we'll get there eventually. It's just a matter of when. We've seen some of the low-hanging fruit optimizations. NVIDIA came out with their new GPUs focused on a lot of networking optimizations. And I've been trying to keep up with all these companies improving their performance and generating more tokens per second, so you can like get more output and maybe use agents to solve more complex tasks faster instead of waiting for the entire output at like 10 tokens per second or something. And a lot of these are software hacks where they, you have a bunch of data, you're trying to train the models, so maybe put all the data in one place instead of having the data distributed across the world, and have enough memory so you can keep the entire model instead of putting pieces of the model together and using that for inference at a time. So I think we're getting really good at optimizing as much as we can to get the most out of these models today, from the software, the operations, to the hardware. I don't know how far away biology is from this kind of a revolution and optimization train.
I think we need to find like some sort of scientist that we can get on here to ask them these questions, because
working in medicine.
Yeah, I don't know, like working on like
tech,
drug research or something. Like, the people who actually use the folded proteins, what do they use that for? Like, I want to talk to them and then like see like how far we are from simulating a cell.
Yeah, that would be a good topic for the next podcast.
Simulating it. Yeah, well, if we could find somebody. But yes.
To our listeners, if you know anyone working on med tech, we would love to hear from them.
Yes, absolutely. Yeah, so I think that's all we have time for.
I think that's time to wrap up.
Yeah, so anyways, thanks everybody. All right, bye-bye.
Until next time.